What's going on, everybody? We're moving on to lesson 4.3. We're going to be reviewing slope, equations of lines, and slope-intercept form. Before we get going, as always, you can go into Canvas. Right, I am obviously creating the 4.3 lesson video, but here are the 4.3 notes, and here are the 4.3 slides. They are already on Canvas. Please utilize them. Well, let's do this. Okay, so slope review, here is a link to a video, an additional video that you can watch to get some additional practice or refresh about slope. Slope is always the vertical change over the horizontal change. You can also say it's the change in y over the change in x. Sometimes it's commonly referred to as rise over run. So in this specific case, right, I don't like when pictures do run and rise, right, because it's rise over run. Personally, I would say that we should go rise and then run. Okay, so the specific slope of this is we go up 1, 2, 3, we go over 1, 2, 3. The slope here is 3 over 3, which can be simplified to just 1. So that specific example has a slope of 1. The actual definition of slope is defined as the steepness of a line. The bigger the slope, or the larger number that the slope is, the more steep the line is going to be. So therefore, if you see that a slope is a fraction, it's going to be less steep than the slope of a whole number, right? And slope is, again, like I said, it's the change in y over the change in x, right? So a different way that you can write slope. Slope-intercept form, y equals mx plus b. I'm sure you've heard this a million times by now, but m is always your slope and b is always your y-intercept. So in this specific example, this would have a slope of 3 and a y-intercept of -1. All right. And so slope-intercept form is on a graph. The y-intercept b is where the line crosses the y-axis. The slope m represents the change in y over the change in x. Remember that the y direction goes up and down. The x direction goes left and right. Just a nice reminder. All right, so if we draw in the lines of these equations, right, we notice here that the m is equal to, whenever there's no number in front of the x, we always know that there's an imaginary 1. So our slope is 1. If we wanted to think of this as a rise over run, we can think of it as 1 over 1. All right. And here our b, or our y-intercept, is going to be -2. All right, there's supposed to be a little space in between there. It's -2. So let's go ahead and plot. -2 is our y-intercept. Our slope is 1 over 1, or just 1. We go up 1 over 1, up 1 over 1, up 1 over 1, so on and so on and so forth. All right, and that would be that line there. If we continue it this way, it would be about like that. That is line 1. For line 2, right, our m, or our y, or sorry, m is slope is 2. But remember, again, if you want to think of it as a fraction, because it's rise over run, we would say that it's 2 over 1. Any whole number is just over 1. And then b, our y-intercept is -5. So we're going to go down here to -5, -1, 2, 3, 4, 5. We're going to go up 2 over 1, 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 so on and so forth. We can go down 2 over 1 that way. And that is going to be our line there. That is line 2. If we do another color, line 3, our slope, or our m, is -1/2. Our b here is -3. Notice all of our y-intercepts are negatives. That's just coincidence. Excuse me, that's just coincidence that all of our y-intercepts are negative. So we go down -3. That's our y-intercept. But now our slope is -1 over 2. So we go down 1 over 2 now. Down 1 over 2. Down 1 over 2. So on and so on and so forth. And this is going to be line 3. And let's do teal for the last one. So here, let's go ahead and change this to +6. So that way it's not just the same thing all the time. Our m is equal to 3/4. And our y-intercept, or our b, is equal to 6. All right, so we go up 6 this time. 1, 2, 3, 4, 5, 6. Positive 6 is our y-intercept, and now we're going up 3/4. So up 1, 2, 3 over 1, 2, 3, 4. All right, notice I'm running out of space going up. If I go down, I just go down 3 in the opposite direction. 4, 1, 2, 3, 4. Because if you think about it, now that we're at this point, we can go up 1, 2, 3 over 1, 2, 3, 4. It's all the same thing. And again, Mr. Stanton does nothing but draw perfectly amazing straight lines. That's line number 4. Now, when you have to write an equation based off of a picture, based off of a graph, right, always find the y-intercept. We see that our y-intercept here is at -1. Let me change the color real quick, right? Our y-intercept, or our b, is -1. All right, now you need to calculate the slope. What is the change in y over the change in x? Well, we see that we have one coordinate here and we have one coordinate here. All right, change in y. Remember, change in y goes up and down. Are we going up? Are we going down? We have to go down, right? This graph is weird. We've got a bunch of lines, but notice it goes by ones over many lines. So it actually only goes down 1. And now it goes to the right, right? And if we think it's going down in the y direction, that's -1. If we go to the right, 1, 2, we're going to the right, which is a +2 in the x direction. So that means that m, or our slope, is -1/2, which means that if we just plug these into our equation, right? Plug 1/2 in for n, or -1/2 in for m, plug in -1 for b, we get y equals -1/2 x minus 1 is your equation. All right, finding the slope based off of 2 points. When we have 2 points or a table with multiple points, we use the equation y1 minus y2 over x1 minus x2 to solve for the slope. Because remember, the slope is the change in y, so we just subtract the 2 y numbers. Over the change in x, we just subtract the 2 x numbers. All right, now that's just to find the slope. Now, if we have to find the entire equation from 2 given points, we find the slope, which is what we just did, right? Same equation, y1 minus y2 over x1 minus x2. To find the rest of the equation, because remember, we need to find the b, or our y-intercept, we plug in the newly found slope for m, plug in the values from one of the points for x and y, and then solve for b. Remember to rewrite it as an equation in the y equals mx plus b form. Okay, so let's do some examples. Again, similar to what we did way back when in chapter 1 with distance formula, I always like to stack my points on top of each other. It keeps it easy to have our x's together and our y's together, right? So if we think these are our x numbers, x1, x2, right, because they're nicely stacked on top of each other, these are our y numbers, y1, and y2. Now we need to find the slope. Our slope, the equation is y1 minus y2 over x1 minus x2. And now we just simply plug those numbers in that we've already found, right? So y1 is 7 minus y2 is 1 over x1, we said was -5, minus x2 is 10. So now we simplify. 7 minus 1 is 6. -5 minus 10 is -15. Now we have to think, can we simplify our fraction? Can we simplify our slope? We can divide both of these numbers by 3, so our slope would reduce to 2 over -5. -2/5 is the slope, equals n. So now that we found the slope, now find the entire equation of the line that passes through the same points, right? So since we're using the same points, luckily we know that the slope is still going to be the same. Nothing has changed there. So we already know that m is equal to -2 over 5. Now we need to find out what b is. We know that our equation is y equals mx plus b. Well, we know that m is -2/5 now. What we don't know is B, right? This is our missing answer here. I will erase that. We'll keep B in blue. And we'll say that what we don't know and what we're missing is red. However, we have 2 points here where we can just simply plug in. We see that X here, this is our X, this is our Y. X is equal to 10, right? So that's equal to 10 plus B, that's still our unknown, is equal to, we know that Y is equal to 1, right? And now we can actually solve for B to find out what our y-intercept is. So in this specific example, this is a little bit challenging because we got a fraction, okay? It's all right. Everything will be okay. Oh, I'm so sorry. Hold on. I said that Y was equal to 1, and then I just wrote Y. All right, so that should be a 1. Okay, so negative 2/5 times 10. Negative 2 times 10 is negative 20. Then divided by 5 is negative 4. So 1 is equal to negative 4 plus B. And then if we're solving for B, we'll add 4 to both sides, and we find out that B is equal to 5, which means that our y-intercept is 5. So now we know our slope is negative 2/5. Our y-intercept is 5. So now we can rewrite the entire equation. Y is equal to negative 2/5 x plus 5 is our whole equation. Okay, now when we find the equation based off of the slope and only 1 point, so now we have the slope and only one other point. When we have the slope and only 1 point, plug in the slope for m and plug in the values from the point for x and y and solve for b. So basically it's the same thing as what we just did. Notice what we just did, we had 2 points, so we got to choose one of the coordinates to plug in for x and plug in for y. Now we only have one coordinate, so we have to use those values for x and y. So our example is write the equation of the line with slope m equals negative 4 and passes through the point negative 4, 8. So remember, this is your x number, this is your y number, that's your m. If we have y equals mx plus b, we have an m, it's negative 4. We have an x number, it's also negative 4. So we're just substituting. We have a y number, it's 8. So 8 is equal to negative 4 times negative 4, and we don't know what b is, so we just rewrite that. That's what we're looking for. Now we solve. 8 is equal to negative 4 times negative 4 is 16 plus b. Now we have to solve for b, so we got to get rid of 16. We subtract 16 from both sides. Those cancel. 8 minus 16 is negative 8 is equal to b. So now our b, or our y-intercept, is negative 8. But remember, it says to write the equation, so we got to rewrite it. Y is equal to negative 4x minus 8. Boom. Okay, here's an example video link and an opportunity for extra credit. Remember, you have to listen to the video, which you're doing right now, hopefully, to know how to do the extra credit, right? Please use the slides from Canvas to get access to the links. So I explained this in class the other day. Go to the PowerPoint slides for 4.3. Click on the PowerPoint slides in Canvas, scroll to this slide, and then you can click on this link to take you to some extra credit practice problems. Once it loads, there we go. Okay, it gives you a bunch of example problems. You complete those problems. At the end, it'll show you what your score is. Take a screenshot of that end screen. Email me that screenshot. That's how you get the extra credit. Okay, let me know if you have any questions, need anything. Go Mustangs.